This lecture is a continuation of 5-3, and I'm looking at the end of example 520, and if you just watch the video on calculator, you can see that because it's a yes or no question, the binomial distribution will always subdivide into left versus right. So what we have is either you need to add things to the left, so 0, 1, 2, 3, this is your binomial CDF, or you need to add things to the right from 3 to 20, so you'll do 1 minus, and then you CDF the 2. You see the left bar, the one that's left and right. So stare at those two pictures, and if anything, I'll continue this in class on individual questions. The last thing in 5-3 is the mean, the variance, and standard deviation of a binomial distribution. Now the chances are, if you draw a histogram of those n is equal to 20, you'll notice there is a bar in the middle. So if you take a look at this 5-20 example, you could draw these up. You know that the probability of exactly 5 is 0.2. We don't know too much information, so this is going to be more of a sketch than a graph. But I know it starts with a 0, ends with a 20, and it'll probably look something like this. Okay, now you should be able to observe a mean, and you should be able to study the spread, the standard deviation. So the mean is given to us as a formula n times p. The variance is n times p times q, and standard deviation is the square root of variance, which is just the square root of npq. Okay, so what I'm going to talk about is example 5-23. It's an 8-sided die with numbers 1 through 8 on the faces, and it's rolled 560 times. Find the mean, variance, and standard deviation of the number 7 that will be rolled. Now, this number 7 is not going to come into play. What we have is we have an 8-sided die, and if I have an 8-sided die, to find the probability of success is a theoretical probability. So I'll give you two examples in this particular video. One that has to do with theoretical probability, and the other one observational. So the observation is going to be a little bit easier because the probability is going to be just given to you. But in the case of theoretical, this is your basic examples out of 4-1, and this is exactly what we were doing, chapter 4 in the beginning of the semester. Just to be able to answer some of the simpler questions here. If you can tackle the hard ones, then you could certainly do this one. So if I'm rolling an 8-sided die, I'm interested in getting a 7. The probability of getting a 7, so getting a 7, that's my success. This is success. So the probability of getting a 7 is 1 out of 8. That means the Q is 7 out of 8, if we ever need it. An 8-sided die is rolled 560 times. Well, that's n. We're looking for mean and standard deviation, really. So this is a population. It's a parameter because we're talking about the whole distribution. So the mu can be found by multiplying n times p. This is just a calculator problem. You'll end up with a mean of 70. In order to find a standard deviation, you're going to take a square root of n times p times q. So carefully put this into your calculator. You'll end up taking a square root of 61.25, which is approximately 7.826. So if you know the formula, finding the measure of central tendency and the spread is actually fairly easy. My next example is 5-24. The Sourcebook of Criminal Justice Statistics states that 65% of Americans favor sentencing drunk drivers in jail even if they have not caused an accident. So that's my probability of success. Sentencing drunk drivers in jail to jail even if they did not cause an accident. So the probability of 65%, that's my probability of success. I'm going to continue reading. If a random number of 1,000 individuals is selected, so they gave me the fact that they studied 1,000 individuals. Find the mean, the variance, and standard deviation of people who feel this way. So I found Q, the P was given to me. The Q is therefore 1 minus P. If they're looking for the mean, this is not theoretical probability. There's nothing to find. The observational probability, those are going to be given to you. So all you're really doing is just taking an n, multiplying it by p. So you have your mean of 650 people. You need variance. Find the sigma squared first. N times p times q. So you're going to take your 1,000, multiply it by the p of 0.65. Multiply it by q of 0.35. This is a calculator problem. Just put it into your calculator. You have 227.5. Make sure that you're able to use your calculator. Otherwise, come in during class and ask me questions on your calculator. And then in order for you to find standard deviation, I'm going to take a square root of previous answer to get approximately 15.083. There's even more digits that I need, but this is good. This is the end of 5-3, and in fact the end of chapter 5 for us. The 5-4 covers the other types of discrete probability distributions that are just not covered in our class.